Okay everyone, I'm doing a video so that you'll know how to use screencast-o-matic if you want to prepare videos for students. Now what you're seeing right now is just my desktop so that I can show you all the steps that I go through before I actually, download the program and use it. See, there's my desktop items over there. I've just moved it so you don't get distracted by that. Mind you, okay, so the first thing I do, I go to Google Chrome, so I suggest you do that too. Open that up. And then within Google Chrome, just type in screencast-o-matic. There it is there. Now, this has come up first time. Sometimes it doesn't. There's another recording program called Screencast. You don't want that. You really want screencast-o-matic. Sometimes it has a little blue circle beside it with a dot in the middle of it. That's one way of knowing that it is that one. Okay, this comes up. It's a little bit larger. Let me see if I can... No, I can't make that screen any bigger. Must be able to. No, it's not going to let me. All right, so there's a couple of bits over to the side there, but this is the bit you're looking for. So just start recording for free. Launch free recorder. Okay, so mine's already open, so it's not going to, it won't sort of open up another one on top of it. So I'm going to get rid of that now. And I'm going to show you what you would normally see. Okay, so if I get up a Word document, I'm kind of getting ready for my next bit. But how about if I go File, New, Document. Okay, now I just want to show you what you would see. I'm going to pause this recording and I'll get a little screenshot that I saved before that shows what you're going to see after you click Launch. So this is what you're going to see. Now, when I took this screenshot, I was actually using Microsoft Edge. I don't know how. Normally I just use Google Chrome, but anyway, so this came up saying, do you mean to switch apps? Do you want to switch from Edge to Screen, Recorder? Yes, you do want that to happen. See this under here though? It's saying launching recorder. So it does that. It even says if nothing happens from the browser, download here. You won't need to. Just wait for it. Then you'll get another shot after that. That will say that it's about to begin, and then you'll get the actual rectangle with the dotted lines around the outside, a little recorder button down in the corner, and something telling you that you've got 15 minutes. All you do is press record when you're ready. If you haven't thought about getting a Word document up before that time, that's the time to do it. Now I have done that. So here I am with my blank sheet that says Pythagoras. And if I was doing this with students, I would probably have that already prepared. And then I would say to them, right, well, the goal of today is that students will know something about the man Pythagoras, and that students will know the formula a squared plus b squared equals c squared and use it to find c. Then I would ask them to use their ruler and a pencil and to draw up this triangle here, making sure that the lines are very straight and using the lines that are on their squared paper. I'd ask them to make this 3 centimetres and to make this 4 centimetres, and then to measure how long this side was. I'd also tell them to pause the recording while they did that, and then to play it again once they have measured that side and drawn up their triangle. Then, of course, they're going to find that that side is 5 centimetres long. I'd move straight from here into talking about how the formula works, the a squared, the b squared, etc. I guess I would do it just like this. I would say, we call this side A, we call this side B, and we call this side C when we are doing using Pythagoras' theorem. In fact, probably it would be more effective if I use draw, gives me different coloured pens. Oh, that's a nice coloured pen. And if I say this is A, this side is B, and this side is C, which is a bit of a blobby pen, but at least it's got a bit of colour to it. I might change that, draw, and we'll go for, say, purple. Okay, and I'll say to them, the next step that I want them to do is to very carefully, with a ruler again, measure 3 centimetres there, 3 centimetres there, connect it up, that should also be 3 centimetres, and create a square. I would ask them to do the same on this side. Draw a square that is 4 centimetres by 4 centimetres, making sure that it really is square using their rulers. And then I would ask them finally to make a square coming off the diagonal, making sure that it really is 5 centimetres by 5 centimetres. Of course, it's important that they place that triangle, as we know, kind of centre page so that they can fit this large square in. Okay, you all know probably how this works. Then, I would tell them to find the area of each of the squares. Let's try a different colour again. Okay, so I would ask them to find the area, and I would write it up as centimetres squared. And then, of course, that would lead me into asking them whether they noticed anything. 9 plus 16 equals 25. Do they notice anything, any relationship between 9 and 3, between 16 and 4, or between 25 and 5? And whoops, already put the answer in there. And what do you reckon the chances are of having a student that will know that 9 is 3 squared, 16 is 4 squared, and 25 is 5 squared? Of course, you'd probably have to explain that means 3 times 3, that means 4 times 4, and that means 5 times 5. Okay, the next step from here is that I would say, let's try some of these triangles together. Let's see the kinds of examples that you might get where you have to use this. Okay, here we've got 2 examples where we need to use Pythagoras' theorem. Classic examples, of course, that students get are things like, there is this second one is probably the kind where you say there is a boat that, 2 boats, one that leave the same point, one goes 21 kilometres in an easterly direction and one goes 28 kilometres in a southerly direction. After so much time, how far away are they from one another? That kind of thing. The context isn't so important right now. It's just about you seeing the kinds of things that you can show students. Okay, so this is where we're going to use the formula together. We've done show the formula, now it's use the formula together. First thing we do is we write down the formula every time. A squared plus B squared, whoops, equals C squared. Okay, and then we identify which is A, which is B, which is C. Right, now I'm going to substitute in this formula. That means that where I see A, I write down what I know to be the value of A. So that is 6 squared plus where I see B, I write down 8 squared equals, I don't know what C is, so I just leave that as C squared. 6 times 6 is 6 squared. 6 times 6 is 36. 8 squared means 8 times 8, and 8 times 8 is 64, and that is still going to equal something squared. 36 plus 64 is 100, and that equals something squared. Now, some of you know what that equals squared, but some of you don't. Now, if I want to find what it is, I have to do the opposite operation. It's a little bit like when we were doing equations and we had x plus 2 equals 7. If I have to find out what x is, I have to take away 2. So I do the opposite thing to what was happening before. Now, the opposite of the squared of a number is the square root of a number. Now, that has got rid of that squared symbol. The square root of a number means what times by itself gives me that number. Now, 10 times 10 gives me 100, so the square root of 100 is 10. So that is my answer to C. Let's do this last one together, and then you can try a couple on your own. Always start with the formula first. A squared plus B squared equals C squared. We'll call this A, we'll call this B. Now I substitute in the formula. Wherever I see A, instead of A, I'm going to write 21 squared plus, instead of b, I'm going to write 28. But I have to remember to square it, and that equals c squared. There's c over here. I've got no idea what c is at this stage. Then I have to work out what 21 times 21 is and what 28 times 28 is. Now, I don't know that off the top of my head, so I'm going to pause it, find those, and put them in. Okay, so I used Excel actually, and I've got 441 plus 784 equals c squared, and 441 plus 785 is 1225, and that is something squared. I've also used Excel to find what is the square root of that, because I don't know that. And the square root of that is 35. So C is 35 kilometres. Now you know the basics of how to use Pythagoras. I want you to keep this, okay? Keep this recording, go back to it when you need to. On the next page, there's going to be a couple of examples that I want you to try on your own. If you feel uncertain, pause it, go back, look at how we did these other ones. If you're not sure about what square root means or where it is on your calculator, ask your teacher. Okay, but otherwise, you are well on your way to being able to use Pythagoras' theorem, which is very handy for life. Okay, here are the two examples that I want you to try on your own. Draw those sketches in your book, then have a go. Remember, formula first, then substitute. You won't always get a whole number when you're working these out. You might get a decimal number. That's okay. Do your best and bring that work with you tomorrow. For teachers who are watching this, that's what I would do. That's I guess that's a bit of a rundown of an introduction to Pythagoras. That's how I use screencast-o-matic. That's also how I mark essays. I just put the camera on it and I show them what I'm thinking, about how I read it, how I correct it as I'm going, and that way there's no excuse for getting the same mistakes another time. So I hope that was helpful. Come and see me if you have any questions about it. Thank you.